Let's start off, everyone. In the last class, we started doing graphs. So we did VT graph. Great. Let's go ahead. Next thing is your acceleration time graph. So in an AT graph, so the area above the time axis is positive area. Area below is your negative area. So here the slope is given by dA by dt. There's a name for this. It's called jerk, but we don't use this. It rarely comes in physics. The area is important. Area will be integral ADT, which is change in velocity. So be careful. Area under AT graph doesn't give you velocity. It gives you change in velocity. V final minus U initial. Clear with this? Then we have the other two graphs. Let's see them also. So this is an AT graph. Others, keep your cams on. The other two graphs are acceleration position graph. This is your AX graph. So be careful. Most people mess up between AT and AX graph. Both are not same. So if you take an AX graph, again, above the x-axis is positive, below the x-axis is negative area. So whenever they ask you area under the graph, you have to subtract the area. So here the area means is integral ADX. This gives you V square minus U square by 2. So the area under AX graph gives you, can you see it looks like V square minus U square is equal to 2AS. So in AX graph, area will give you V square minus U square by 2. AT graph, area gives you change in velocity. Hope you're getting the difference. Both are completely two different things. Here slope is dA by dx. It has no meaning, so we'll not use it. And the last standard graph is your velocity position graph. So these are the main 5 graphs actually: xt graph, vt graph, at graph, ax, and vx. Av graph doesn't make anything, so we'll not write it. So vx graph. So here, let's say if you take a point P here, and this is velocity P here, the only slope has no meaning. So if we take slope here, dv by dx has no meaning, but we know acceleration is also given by the second form, is v dv by dx. That means if you multiply velocity at a point into the slope at a point, that will give you the acceleration. So in a Vx graph, only slope has no meaning, but the slope into velocity will give you acceleration. That has a meaning. And area is Vdx, again has no meaning. Yeah, there's no meaning for this. That's it. These are the 5 standard graphs. You will also see what happens if you have a non-standard graph. Have a look at this. All clear with the graphs? Great. Let's see a few questions then. There you can see. So AT graph, area gives you change in velocity. AX graph, area gives you v square minus u square by 2. VX graph, velocity into slope gives you acceleration. Great. Let's see a question. This is acceleration time graph. Let's say this is 10 meter per second square. 10 seconds, 20 seconds. Initial velocity is minus 50 meters per second. First question. Find velocity at t is equal to 12 seconds. Find the time when the particle comes to rest. Let's get this. Remember, this is an AT graph. Area gives you change in velocity. Initial velocity is minus 50. Try. You got a minute or so for the first part. 68 and 5. Samek, it comes to rest only once. First was easy. You just need to find the area till 12 seconds. So where is 12 seconds? 12 seconds will be somewhere here. That will be 12. This will be 10. So I want you to find this area and this area. So this square ka area is 10 into 10. That is 100. That small trapezium ka area will be how much? This is 2 seconds. This height will be 10. And you can see this height will be 8. Are you getting how I got that height 8? Because this angle is 45 degrees, right? If this is 8, this height also must be 8. Sure. The area of this trapezium will be half into sum of the parallel sides by, so that will be half into 10 plus 8 into 2. That is 18. So area up to 12 seconds is 118. They're just little geometry. So area up to t is equal to 12 seconds is 118. So you're saying this is change in velocity. So v final minus v initial is 118. So v final minus v initial is already minus, so that is minus of 50 is 118. Therefore v final is 68 meters per second. Exactly, everyone. It's just all areas. There's nothing big to solve. Right, Arya? Right, Ishman? Right, Aditi? Right, Samir? What about the second part? Find the time when the particle stops. Any doubts on the A part? Just finding area and finishing it off. Can you get the B part? Find the time when the particle comes to rest. That is okay, Ishman, but there is one more answer. Sri Hari, there is one more answer. Yeah, let's see. So, right, Utsa, but there is one more answer. There are two answers for the second part. So you want to find the time when it comes to rest. That means initial is let's see, Arya. That second one looks a little goofy. So your initial velocity is minus 50. That means if you can make the area plus 50, then won't it just cancel out? So the first possibility is you need not even go much further. You can just go till here, 5 seconds. So if you go only till here, 5 seconds, this is 10 meter per second square. This area will be 50. So here area will be delta V, which is 50. This will be V minus of minus 50 is equal to 50. You got V minus finally is 0. So this is one answer. At 5 seconds, you come to rest. Agreed with this? There's a second possibility. Now see, after this, what will happen? This area will be positive. This area will be negative. So again, it will come to rest, right? So you know, how is this particle actually going? This particle is going backward, but acceleration is forward. So this particle will go stop, then it will take a turn. And as it is going forward, after some time, 20 seconds, the acceleration became negative. So after some time, velocity is forward, but acceleration is backward. So again, it will go stop and then will come back. You're getting this particle is going front and back. It stops twice. So the second possibility is this. This area is 100. This area is 50. We have done last time, velocity ka thing. This was 20 seconds. This was t. So this distance will be t minus 20. This is 45. So this is also t minus 20. So this area will be half into t minus 20 square. Therefore, area will be, the positive area is 150. The negative area is half into t minus 20 square. So you're saying V final must be 0. So this is V final minus V initial. So this is 150 minus half into t minus 20 square. If V final is 0 and V initial is minus of minus 50, it will come this side. This will be 100 half into t minus 20 square. So that will be 200. So will be t is equal to 20 plus 10 root 2. This is the second time when it comes to rest. Is this making sense, everyone? Yeah, got it. Ishman got it. It's not 10 root 3. Check it out. See where it went wrong. Remember, the V final is minus, so you'll always get minus or minus there. So there are two times when it will come to rest.
So can you show the previous slide, please? Okay.
Others, any other doubts on this? All clear with this? Next one. There. Let's get this question. This is a good theoretical question. So this is a AT graph, and these are the four options. So if you see the acceleration here, it is increasing and then decreasing.
So is it multiple correct?
If it is multiple correct, then give me the multiple correct answer. If you think it is multiple correct, then tell me what are the multiple correct answers. Okay, Samyak got one answer. We don't know what it is. Let's see. Any other answer? Okay, Ishman says something. Siddesh also says A. Arya also says A. Yeah, most common answer is A. That's a trap. So let's see what is the thing. Triya and Samyak got it. Now listen. Here the acceleration is increasing and decreasing. Okay. Let's try to understand the meaning of it. But acceleration is always positive. Here, if you look at the graph, acceleration is increasing and decreasing. But it is always positive. Okay. So I'll give an analogy. See, think of like this. Let's say, what is the meaning of acceleration? If I say A is 10 meter per second square, what is the meaning of this? The meaning of this is every second your speed will increase by 10 meter per second. Do you agree? This is the meaning of it. So let's say, for example, every 1 second the acceleration is 10, 9, 8, 7, so on. Your initial speed is 0. You tell me, after 1 second, what will be your speed? 10 meter per second. Let's say your acceleration became 9 meter per second square. Now what will be the velocity? Whatever is your initial speed, you will get extra 9, isn't it? If your acceleration becomes 9, your speed becomes now 19. If your acceleration is 8, then your speed becomes 19 plus 8. Are you getting this? 27. If your acceleration becomes 7, then your velocity becomes 36. If your acceleration becomes 6, then velocity becomes 42. Did you notice something? Acceleration is decreasing, but speed is still increasing, isn't it? It is not increasing as fast as before. Are you getting the meaning of this? The misconcept you guys are doing is, since A is decreasing, speed also should decrease. What is A? A is telling you the rate of change of velocity, means A is telling you how much the velocity will change. If A ka value is decreasing, that means the speed is still increasing. As long as it is positive, speed will still increase, but it is not increasing as fast as before. Is that making sense? So now you tell me what is happening here. So when will the speed decrease? If A becomes negative, isn't it? Let's say after this, A becomes -3. Means what? Next second, the speed will go from 40 to -3, 39, isn't it? Velocity will decrease when acceleration becomes negative. As long as it is positive, the velocity will keep increasing. Maybe it is not increasing at a faster rate. Is this logic making sense? Any doubts on that statement? So here, as long as A is positive, means you're still pushing forward, right? If I'm pushing you forward, you will keep going forward faster and faster. So if I push you little less, you will still go faster, but you will not go, with more acceleration. So your speed is not increasing as much as before. Since A is positive, velocity will increase. And since A is decreasing, it will not increase at a faster rate. It will increase at a slower rate, but it will still increase. Now, can you tell me what is the answer? Velocity increases at a slower rate. That is the meaning of A decreasing. It doesn't mean you'll slow down. You want to slow down, A should be negative. Velocity increases at a slower rate. Yeah, if A is negative, then this velocity decreases. So if the graph had gone below, then it would have decreased. So first option is gone. Second option is gone. D option, there is only answer left. Displacement velocity, both will keep increasing. All got this? Yeah, now you don't got it. So be careful with that. A is increasing and decreasing. That has nothing to do with velocity. Velocity will always increase. Are you clear with this? If you try to see this mathematically, also think of like this. If I take till here, this is the area. Area under the graph is what? Velocity. If I take till here, this is the area. Did the area increase or decrease? Area is increasing. Till here, area increased. Till here, area increased. The area is always increasing. So the velocity will always increase. Clear? Let's see one more. I'll keep these numbers here. So why is this not getting updated? Okay, let's do this in the meantime. So there I gave you 4 graphs. Which of the graphs are not possible? Or which of the graphs are possible? Okay, it's a multiple choice question.
So what are the third and fourth graphs with?
Total path length doesn't matter. ठीक है, but still if you want, I'll give you time से ले लेना. Hmm. Nah, all are giving, but I'm waiting. Someone will give full answer. Everyone is missing one option, right? Right, Samyak. None of the graphs are possible. All are wrong. Look at the first one. XT graph. What is the problem with this? At the same time, you're in two different positions, isn't it? Time can't be negative also. That is anyway there. This is also not possible. So if you see at the same time, you're at two different positions. Until unless you are a god or something, like you have an alien creature where you can split into two parts, you can't do this. So at same time, particle is at two positions. Here also you can do the same argument. Time is negative. At the same time, you have two velocities. Speed can't be negative. Speed is a magnitude. Total path length means this is distance. Distance can never decrease, isn't it? Whether you go front or back, distance will always keep increasing. Distance is always an increasing function. You cannot have a graph. This part is a problem. You can't have a function decreasing. So here, this thing decreases. It doesn't matter whether you go front or back, distance will always increase. All four are not possible. Clear with this? There. You get these kind of questions, good ones, theoretical ones. Let's see one more. Let's say this is a V and X graph. Let's say this is a graph V is equal to 2x square. Find acceleration at x is equal to 2. So these are little, they'll give you the curves if you don't have any standard stuff. Find time to go from x is equal to 1 meter to 2 meters. ATE minus 664. Yeah, first one is 64. Here's the second one. You can just use VdV by dx, right? There's nothing to do with the graph actually. So the first was easy. V is 2x square. So dv by dx will be 4x. And we know acceleration is v into dv by dx, the slope. So that is 2x square and 4x. That will be 8x cube. You said x is equal to 2. That will be 64 meter per second square. Hmm. Right, Ishman. Get the second part, find the time also. Right आ गया. नहीं हो गया. Time is not right. नहीं श्रीहरि. 1/2 नहीं श्रीहरि नहीं है देते. You want to find time, right? So yeah, so v is equal to 2x square. What is v as? Dx by dt. Since you want time in terms of x, get v in terms of dx by dt. This will be dx by x square is 2 dt. Integrate 0 to t, and you're going from where to where? You're going from 1 to 2. So limits will be x is equal to 1 to x is equal to 2. This is x power n ka integration. This is x power minus 2 plus 1 by minus 2 plus 1. Limits will go from 1 to 2. This is 2t. That will be minus 1 by x. Limits will go from 1 to 2. Substitute 2 there, that will be half, and substitute 1 there, that will be 1, which is 2t. That becomes half, 1/4 of a second. Check. So if they give you some curve equations and all, you get back to your, again, calculus. It's nothing to do with the graphs. Right, Utsa. Clear with this? Let's see, did this thing load by now? Why is this not loading? ठीक है. Let's do this one in the meantime. You can also bring questions in the projectile motion ka graph. Look at this thing. A particle is projected from a level ground making an angle theta. The vertical component Vy changes with the x coordinate. So this is a graph between Vy versus x coordinate. Right? So this is the velocity versus x coordinate. So he is asking find calculate theta. Theta is the angle of projection. This value is 10. So this particle is projected with u and theta. U is not given, theta is not given. This is a graph between Vy and the vertical component and the x coordinate. Using this information, he's asking you find the angle of projection. How do we approach this? I'll send you a small sheet on graphs today. Only graphs, like 20-25 questions. You can try them. That will make things clear. We'll wrap up a little early today. Most of the chapter is almost done. Any idea how to approach this? Think. I'll give you another 2 minutes. It's a good one. There are some data points here, if you can clearly see. This is 45, this is 10. Matlab, this is also 10. Right, Arya. That is one. Second thing, did you notice something? At this point here, Vy became 0. You tell me during projectile motion, when does Vy become 0?
Right.
At h max. So that means that was h max. And the x coordinate must be half of the range. Right, Siddesh. So see, now we can think of something. नहीं यशमान अच्छा नंबर आएगा रे. That's it. The graph, projectile range, that is just to scare you. If you can just see the data properly, you'll get it. Right, Shreyansh. Right हो गया. Right, Shreyansh. See, so this thing, right? If this will be your initial velocity, which is u sine theta. At t0, Vy is u sine theta. This is 10. That is 45. So tan 45 must be u sine theta by 10. So we got u sine theta is equal to 10. Great. Next thing, at this point, Vy is 0. So this must be h max. Right? Or x is equal to r by 2. Same thing. So that means when this projectile is projected there, at this point, Vy becomes 0. At this instant, the x coordinate, he's saying this is r by 2, which is 10 meters. This is another r by 2. So indirectly, he gave you the ranges 10 by 2 meters. So r by 2 is 10 meters. So range is 20 meters. And range is nothing but u square sine 2 theta by 2g is equal to 20 meters. So what is u square sine 2 theta? U square 2 sine theta cos theta, that will become 400. But I already know u sine theta is 10. So from here you'll get u cos theta is also equal to 10. Take this and substitute here. Then you're done. So just divide u sine theta and u cos theta. I can even find the initial speed. Theta is 45. Clear with this? Easy? Any doubts on this? So that is the main catch there. So at 10, that coordinate, right, Vy has become 0. I can find everything. I can find the speed. I can find the time of flight. I can find everything now. Once you know u and theta. And u ka value is how much? 10 root 2. All clear with this? Next one. This is a Vx graph. Can you plot Ax graph? Exam you'll have 4 options like this. Like this, like this, like this, like this. Is a 4 quadrants, they'll give 4 graphs. They'll ask you which one is right. So can you just draw that graph? If this is your Vx graph, plot Ax graph. Think. Shman got it. Let's see. मेरे आ गया. हाँ, but which quadrant होता? First quadrant नहीं है. हाँ, right, Aditya. See, how to do this mathematically, I can do there. This thing is a straight line passing through the origin. So V is equal to, we can clearly see it's a negative slope. V is equal to minus mx plus c. Agreed? This would be the equation of that line. This is how it looks. It's a negative slope. Here m and c are positive. What is acceleration? Acceleration is v dv by dx. This will be minus mx plus c into dv by dx is minus m. So a will be m square x minus mc. How will this line look like? So this is a line with a positive slope and a negative intercept. So if you try to plot this graph, I'm plotting an AX graph. I think it should be in the fourth quadrant, right? Why? Because X is positive. X is positive on the right hand side, and you want a positive slope and a negative intercept. So the graph should look like this. I think that's what you draw, na, Arya? You are right, Arya. I mistook it. Got the answer? X has to be positive because X is positive coordinate. So the only answer can be in first quadrant or fourth quadrant. That is the only doubt. So, but you can see the negative y-intercept. When x is 0, a must be negative. So the graph looks like this. All got this? Easy? Let's see one more. Let's say this is a v t square graph. Let me ask you like this. So you can get non-standard graphs. Let's say this is v t square graph. Let's say this is v x graph. Let's say this is v square t graph. Let's say this is x square t graph. Let's say this is v x square graph. So among these 5 options, in which case the acceleration is, or let me ask you like this, describe the acceleration. Is it uniform, non-uniform, Esa? So in which case the acceleration is uniform or acceleration is non-uniform. This could be a matrix matching. So they'll give you options on the left, on the right side, they'll ask you like this. Speed is increasing, speed is decreasing, A is increasing, A is decreasing, A is constant, A is non-uniform. So you'll have options like this. But okay, we'll just keep it simple for now, in which case acceleration is non-uniform. These are non-standard graphs. Every time you won't get xt, vt, at. This is vt square graph. This is vt square graph. This is a standard graph, vx. This is v square t graph. This is x square t graph. This is vx square graph. You can play with anything. So if I give you a graph like this, and if I ask you which case the acceleration is non-uniform, how will you approach this? It doesn't matter what is the angle. I don't want the exact values, no? Take a minute, how will you approach? Take your time. Take a minute or two. I don't know the answer, so there's no point in typing. Even I need to try. I thought v and x square are looking good. I just made up some numbers. If they ask you a non-standard graph, the only way is to find the equation of that line or the curve and then solve using calculus. There's no other way. You can't do anything in general with non-standard graphs. Let's see, I'll show you one. Look at the first graph. So this is a straight line, right? I don't know how is this exactly, but I know this thing looks like v is equal to some constant slope m into t square plus c. Can I write like this? It looks like y is equal to mx plus c. X ka place mein you have t square. Then differentiate it. Acceleration is dv by dt. This comes out to be 2mt. A is not constant, A is increasing with time. So A is proportional to time. This is non-uniform. Are you getting? So this A is increasing. So I can ask you that option also. Acceleration is non-uniform and increasing with time. So you can create options of that sort. Look at this thing. This is a straight line. So V is equal to mx. Acceleration is V dv by dx. So this is mx and that is m. This is m square x. X is increasing. A is also increasing. This is also non-uniform and increasing with x. Are you getting how to do? Now can you try remaining three? Looks like all will be non-uniform. I don't know. I'm guessing. You can just take it as slope m and do it. Okay, A, C, B, E. Let's see. Okay. Yeah, मुझे लग रहा है सब non-uniform है. So I can ask you like this: in which case acceleration is non-uniform, increasing, decreasing? Maybe I can make up more options. I could have given more graphs, but you got the point. If I give you a non-standard graph, you have to find an equation and solve. Most of the time, that is the case. Yeah, सब non-uniform मुझे भी लग रहा है. So for C, it is V square is equal to KT. So V is equal to root KT. So acceleration will be dv by dt. This will be 1 by It will be root k by 2 root t. Yeah, this is non-uniform and decreasing with time. The time comes in the denominator. No, I think that would have been a better question. Which of the following is uniform or non-uniform? Which of the following is increasing and decreasing? You can play like that. If you look at the D option, this will be x square is equal to kt. This also x will be k root t. Differentiate, so we get velocity is dx by dt. This actually becomes like that only. This will be root k by 2 root t. Yeah, if you differentiate this again, root k by 2, 1 by root t ka differential will be minus half. So this will be minus 1 by 4 t power 3 by 2. This is also non-uniform and decreasing. E ka graph v is equal to kx square. Acceleration will be v dv by dx. This is kx square into 2kx. Yeah, this is definitely increasing. All are non-uniform, but this is increasing. Clear with this? So there, get the slope, get the equations and finish it off. Let's see one more like this. All clear with this? Let's see if this thing has come or not. Why is this not getting uploaded? Okay. Let me just write down this thing on a paper. Let's see this. Let's say we have a graph v square x cube. Let's say this is 45 degrees and this point is 100. Find acceleration at x is equal to 1. Check, yeah, it's not getting uploaded. ठीक है, let it be. Like I said, get the equation between v square and x cube, and then it is simply calculus. 3 by 2. Okay, let's see. Anyone else got the 3 by 2? Three by 2. Ishman also got it, so maybe right. Right, it's a 3 by 2, 3 by 2. Yeah, most of you are getting 3 by 2. So if you look at this function here, this looks like v square is equal to mx plus c. So slope is 1. So that is x, sorry, this is x cube. X ka place mein x cube is there. So that is x cube plus the intercept is 100. Differentiate on both sides. If you differentiate on both sides with respect to x, I can directly use the chain rule here. It looks scary. It is actually easy. So v square ka differential will be 2v, then differentiate whatever is inside dv by dx. That will be 3x square. Luckily, v dv by dx is the acceleration, isn't it? If you want, you can do dv by dx and then do all that stuff chain rule, but this is much faster. This will be 3x square by 2. This is nothing but acceleration. And you said x is equal to 1. 3 by 2. Easy? So don't find v in terms of x and then differentiate. It will be lengthy. Directly differentiate v square. So if you differentiate v of square with the d by dx, we are using chain rule. It is 2 into the function, then differentiate whatever is inside. Luckily, that term becomes the acceleration term directly. Clear? That's the faster way. Any doubts on this? Go take a small break. Come back by 9:35. Any doubts so far? Yeah, most of you got 3 by 2. Chalo, come back in 5 minutes. Let's get this thing. This is an AX graph. Other scams one. Let's start off. Ten root 5, 10 root 6, 10 root 3. Be careful. This is an AX graph. So what does area give you? Area in AX graph gives you V square minus U square by 2. Hope you remember that. It's not delta V. It's an AX graph. That's it. There's nothing more about the question. Most people goof up that part. They think it's a AT graph. So what is area under the graph? It is half into base into height. V square, U square is minus 20 square. Actually, the sign won't matter here. That would be 100 and this will be 400. So V square will be 500. 10 root 5 meters per second. Easy? Hmm. Right, Ishman. Right, Aditi. Right, Shriyansh. Yeah, most of you got it. Right, Vanchika. All got this? Let's see one more. You can see the questions are easy and straightforward. Graphs may one or two they can ask you. I'll show you that also, something which they can ask at an advanced level. Let's say we have a graph like this. This is a Vx graph. This will be there in the assignment which I sent you also, but it's a good question. The graph is a straight line. So it is given acceleration A is given in the form of Cx plus D, right? The graph is looking like this. So this does not happen for everything. So if the graph is a linear function, find the initial speed. Initial speed is velocity at x is equal to 0. This much data you have. This is the Vx graph, which is a linear function, and acceleration is also a linear function. Then find the initial speed. D by root C. How do we approach this?
Sir, I have a doubt in the previous question. Can I ask it?
क्या था?
Sir, actually, what I did was I took A is equals to minus X.
Okay, plus
And
constant. A
sir,
is
why
not
don't
equal to minus X. A is minus X plus 10.
okay, right. Right. That's why. Thank you, sir.
Yeah. How clever this. So how do we start this? Look at this. You said V is a linear function. Fair enough. So I can take V is equal to mx plus, okay, I'm already using C ka symbol, so I'll use like this. V is equal to px plus q, right? So what is the acceleration? V dv by dx. So this is px plus q into dv by dx is p. So this is p square x plus pq. And it is already given in the question, a is nothing but cx plus d. So if you compare the terms, you will get p square is equal to c, and you will get pq is equal to d. So from there, I can find q ka value. So this is there, I got everything. So what is the initial speed? So initial speed will be when x is equal to 0, your speed v is equal to q. So you just have to find q ka value. D is nothing but t by p, and p is nothing but by c, so d by root c. Easy? Is that making sense? Since the velocity is linear function, it is nothing but px plus q. If you differentiate and use v dv by dx, I'll get acceleration. But you already said this acceleration is nothing but cx plus d. So if you compare the coefficients, p square is c and pq is d. At x is equal to 0, velocity will be initial velocity. V becomes equal to q. So q is d by p and p is root c. Any doubts on this? Easy stuff. Yeah, right, Utsa. Next one. Let's say we have a graph between x and 1 by v. Like I said, it's all non-standard graphs. It's not between x and v, it is x and 1 by v ka graph. And the graph is looking like this. This point is 2. This point is 8. This point is 3. This point is 15. This is the graph. Find the time taken to go from x is equal to 3 to x is equal to 15. Remember x coordinate here, x is on the y-axis. Ah, yeah, you can do that also. Which one you're talking about, this thing? The previous question. The area and all, you're saying
Yes, sir.
something.
Yeah.
हाँ, वो भी सही idea है. This comes a little faster, और कुछ नहीं. How do you do this thing? It's an x versus 1 by v graph. Find the time taken to go from x to 1 by v. One, you can use brute force and do. There is another easy way to do, but if it strikes. No, Ishwan. That's not the answer. If it is me, the easy method, it won't strike. I to will chupchap. I'll just find the relation between x and 1 by v. It's a linear function. I'll integrate. But there is a much easier way to do this. But let's see. I'll show you that also if it clicks. Nere Samyak. We also got 54. Why are you guys getting 54? Nee, Arya, that's not the answer. Right, Aditya, you got it. $54. How did you even get 54? Did you take the limits properly? Or maybe did I mess up somewhere? Let's see. Oh, yeah, that's not the answer. You thought something else only. We have three answers now: 48, 54, and 60. I think 60 looks right. I could be wrong. Let's see. How do we approach this? First, let's see brute force. This is an equation which is looking a straight line. So this angle is theta. This will be 15 minus 3, 12, 8 minus 2, 6. Tan theta is equal to 2. This looks like a straight line. Y is equal to mx plus c. Y का place में you have x. M का place में we have slope. X का place में we have 1 by v. And plus constant, we need to find that. So when you put at x is equal to 3, 1 by v is equal to 2. If I substitute here, I'll get 3 is equal to 2 into 1 by v is also 2 plus c. So c is nothing but minus 1. So there, this is the relation between them. So x is 2 by v minus 1. Did you guys get this? Then I can write this thing as x plus 1 is 2 by v. I can write this v as, I can just shift it here. So v is equal to 2 by x plus 1. V is nothing but dx by dt. I'll just do one thing here. I'll write it here only. X plus 1 is 2 by dx by dt. Send that dt that side. So it will become x plus 1 dx is equal to 2 dt. Integrate on both sides. Yeah, just a mathematical function there. I got the function from y is equal to mx plus c. If you integrate this, this will be x dx plus dx. Limits are going from 3 to 15. This will be integral to dt. Limits are from 0 to t. X dx is x square by 2 plus x. Limits are 3 to 15 is 2t. Substitute 15 there. How much is that? 225 by 2 plus 15 minus 9 by 2 plus 3. This will be 225 minus 9 is 216. 216 by 2 will be 104 minus 12. 108. Looks like 54 only, I guess. How much is this? 106, 96, 48. I got 48, right? Or did I mess up something? Hope you also got 48.
Sir, I got my mistake and now I'm getting 60.
ठीक है, then I must be messing up somewhere. Did I do anything clear till here? Anyone found any mistake here? Okay, so let me just
so far.
look only now. Let's put the limits again. Put 15 here. 225 by 2 plus 15. Then put 3 there. That will be 9 by 2 plus 3. 225 minus 9 is how much? 216. Yeah, 216 by 2 is 10. That is plus 12. Na? Shit, right? What am I doing? I'm subtracting 108 minus 12. This will be 120. T is 60 seconds. This is brute force. I just found the equation. I integrated. I did this. If this comes in the exam, this is what I will do. This is something you need to understand. You might have a very innovative and very nice approach which will give the answer in like 10-15 seconds. But you need to ask yourself, will it strike in the exam? If you're not confident it will strike, then best stick to the standard generalized method. Even if it takes 2 minutes more, at least you'll get a right answer. So that is the thing you need to understand. Just because you have some innovative 3-4 different methods you have doesn't mean you have to learn everything. Because you need to understand the final exam, 3 hours, 2 years ka portion, 3 different subjects. You will be under full pressure because that exam decides whether you'll go to a college, IIT or not. So will you be in a proper mindset to, think of all innovative methods? I'm telling you, I have made this thing thing. If you ask me something like x square, right? X square plus 5x, something of this sort, x square minus 5x plus 6. If you ask me to find the roots, I'll still use the quadratic roots, minus b plus or minus b square minus 4ac by 2a. I will not try to factorize, I'll not try to do all that nonsense. Because sometimes you can factorize, sometimes you can't factorize. So why should I waste my time in taking a decision? What should I use? So that is how I increased my speed. It looks like it'll take more time, but my speed used to be pretty fast because of that. I do the same thing repetitively for everything. So how to do this in a faster way? Alternate. So learning is nothing wrong with this. Who knows? Exam it might strike. I was dumb, so I couldn't figure it out. Maybe you guys are smart enough. Maybe you will figure it out. So we should learn that way. But knowing about yourself is always important. So this is x, 1 by v. Here, if you see something interesting here, if you do integral 1 by v dx, 1 by v is nothing but dx by dt. This becomes dt, which actually becomes time. That means if you take the area under 1 by v dx graph, you will get time. Now look at this thing here, 1 by v dx, matlab dx must be the base. So you should take this area, everyone. Because see, when you take strips, how will you take the strips? This will be dx. This side will be 1 by v. Isn't it? So the area must be taken on the left-hand side. It's not vertically down. So that area under the graph will give you time. So in an x 1 by v graph, if you give me a graph like this, this area is integral 1 by v dx, and this is time. Yeah, if it clicks, then it is great. Now it is pretty easy to solve. It's a trapezium. This is 12 because that is 15 minus 3. This is 8. This is 15. Area of a trapezium is that 15? Yeah, that is 2 and 8. Half sum of the parallel sides, 8 plus 2 into 12. This comes out to be 60 seconds. हो गया answer. Easy, but it doesn't click. So if it clicks, great. Doesn't click, stick to your regular method. Everyone got this? So this thing is not a vertical area, shall I take the horizontal area? Isn't that the meaning of integration? Take a thin strip, 1 y into dx. So here y ka place may have 1 by y and dx is dx. Any doubts on this? Ishman, this is what you're saying, na? You must have taken the vertical area, I guess. Vertical area kya hoga? If you take the vertical area like this will be integral x into d of 1 by v, na? That's pretty messed up. That means nothing actually. That has no meaning. But area, you do get an answer. All clear with this? These are all graphs and everything. Now there is another type of question they can ask you. They'll give you a physical situation and they'll ask you to draw a graph. Let's do this thing. This will be the last one. We have done this before. A particle is projected with speed u. It goes up, comes down, hits the ground, speed becomes half. Goes up, comes down, speed again becomes half of the previous one. and so on. Remember, we found the average speed for this. A particle is projected with speed u vertically. After hitting the ground, its speed becomes half of the previous speed. After hitting the ground, it bounces back with half the speed. Neglect any time during collision. So during collision, there's actually a slight time interval. We are going to neglect that collision part with the ground. Neglect time interval with collisions during collisions. Remember the sign convention, up positive, down negative. We will stick to that same convention. Plot acceleration time graph, velocity time graph, displacement time graph, distance time graph. VT graph, velocity position graph, position time graph, displacement basically. In this case, it's a y coordinate, so I'll just call it a y. Displacement time graph, distance time graph, total 5 graphs, everyone. If this is the exam, I would ask you VT graph and distance time graph. I can ask you VY graph also. Yeah, get them all, try. First 80 graph is the easiest one. Get the remaining 4. Let's get this. This is the last question for the day and the end of the chapter.
So we are measuring the position with respect to the initial position
The
of the
ground
ball.
level,
Okay.
yeah, ground level is y0. Think. Take 2-3 minutes. Try to draw as many as you can. We'll see. So yeah, got something?
Sir, where do I have to send you the graph?
You can't send actually. इसमें ठीक है ना? When I show you, you can verify. Keep drawing all the 5 graphs. I'll show you the graph, then you can verify. It's okay. Hmm. I'll show you the first one. See, AT graph is easy. Tell me one thing: whether the particle is going up or coming down, what is the acceleration? Always minus g, isn't it? So if they ask you to draw an AT graph, it will be just a line in the negative, in the horizontal to this. It will be like this, -10. It's a constant acceleration. A is equal to minus g. So acceleration doesn't change with time. But you can make this more interesting. Suppose if you consider the collisions, if we consider during collisions, the floor is hitting the ball with huge forces actually. Every time it collides, you get a huge force. The acceleration will be upward, isn't it? That is the reason the ball ka velocity is changing. So the graph, if you try to draw, it would look kind of like this. As it is flying, it will be constant. once it hits the ground, during the time of collision, this thing just spikes. Huge value here, comes down. Then again goes here. Then again it spikes. So you'll get the spikes. So the spikes, right, is the collisions. So during collisions, there's a huge acceleration for a small time. We neglected that. So technically we don't draw on the graphs, but if you actually consider them, this is how the graph would have looked. You're hitting the floor in a very small time and then you're bouncing off. So there's a huge change in velocity in a very small time. You get a huge acceleration. There's a large acceleration. So we represent that with that spikes. The value just goes up and then again comes back to G. Just a theoretical thing. In case if they ask you to consider the collisions also, the graph would have looked something like this. Clear with the AT graph? How would we draw the VT graph? VT graph as triangles, not necessary. It looks like triangles, yeah. Drawing a graph is easy. I want more data points there. Look at the VT graph. If you write the equation V is equal to U minus GT, the first thing, this is the equation of a line. That is okay. Next thing, you will notice something here. See, the time of flight is 2U by G. This is proportional to U. So every time it hits the ground, the time of flight is changing. So if you try to find the total time, you have done this before, the total time will be T plus T by 2 plus T by 4, so on till infinity. This will be T into 1 by 1 minus half. That means the total time of collision is 2T. The graph should end at 2T. The graph cannot go beyond 2T. See how the graph looks. So at T0, your velocity is speed U. It is positive. As time passes, you will go down negative, 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 like this decreases. And look at the data points here. So you're starting with speed U. When you're hitting the ground, your speed becomes minus U. This angle is theta. This angle is theta. In a VT graph, the slope is acceleration, which is minus G. Now what happens? Now when the collision happens, and what about this time? This time is T. Now after the collision gets over, immediately the ball will bounce upward. The speed becomes U by 2. So the graph starts from here. You're getting this a discontinuity in the graph. It is coming down and suddenly it goes up, isn't it? The velocity direction suddenly changed. Again, this also will be a parallel line because the gravity acceleration is constant. This is theta. This time the graph will stop at minus U by 2. So if you look at this time interval, so the graphs are actually becoming smaller and smaller. This will be T by 2. This will be T. So the graph ka height is becoming half. The time is also becoming half. Then again it will hit the ground. The velocity becomes U by 4. Again you'll get one more parallel line. Theta. This will go to U by 4 minus U by 4. Then you'll get again one more parallel line. You'll get parallel lines. Parallel line. Parallel line. It becomes smaller and smaller. And eventually the graph will end at 2T. You cannot exceed this point. This time interval will become T by 4 and the next time interval will become T by 8. It's getting closer and closer and the heights are becoming closer and closer. This will be U by 8, U by 16 and so on. This is how the graph looks. It's a discontinuous graph. Yeah, it does look like little triangles, but I hope you got it. So exam there'll be two options. Most people will realize you have parallel lines. Most people don't realize this. There'll be an option like this. The graph is going till infinity. Now, most people will think since there are infinite collisions, graph also will go till infinity. That would be the mistake. The graph will end at t by 2t. Is the graph clear, everyone? This is how a VT graph looks for this situation. Every time it hits the floor, the speed is minus u. It suddenly goes up with u by 2. So the graph will suddenly jump to u by 2. It will go from minus u to u by 2. It will go from minus u by 2 to u by 4 and so on. Any doubts on this? These are one of the most important graphs. At an advanced level, these are the kind of questions they'll ask you. See how many things I combined here. Kinematics, infinite GP, and the graphs. The next thing, velocity displacement graph, Vy graph. If you write the equation, V square is equal to u square minus 2gy. This is V square is equal to minus 2gy plus u square. This is a parabola. So how does this parabola look like? Now, I'll give you a little info here. Look at the graphs, how they look. If you draw like this is an upward parabola. This equation will look like y is equal to ax square. This is an upward opening parabola. Look at that. With x is positive or negative, y is always positive. You will learn this in max graphs, but little idea here. Suppose same thing, if I invert this parabola, the equation becomes y is equal to minus ax square. This is a downward parabola. If you draw like this is a horizontal parabola. This will be y square is equal to ax. Did you see? This becomes y square here. Or you can say, yeah, y square is equal to x. This is a horizontal parabola. If you write it like this is y square is equal to minus ax. This is a horizontal left parabola. Now for this parabola, if I do something, if you say y square is equal to minus ax plus some number constant, what are you doing? You are adding for every x coordinate 1, right? If you put x is equal to 0, right? Or if you put x is equal to plus 1, then you will get something like 0. So the parabola will look like this. You're just shifting the parabola right side by 1 unit. That is the meaning of plus 1. You're shifting the parabola by 1 unit. If you say y square is equal to minus ax minus 1, that means you're shifting the parabola by 1 unit on the left hand side. You're shifting it. That is the meaning of this graph. So if you add a number to it, you're shifting the graph. Other graphs clear, everyone? Now look at this graph, especially here. Y square is equal to minus ax plus 1. Doesn't this look like v square is equal to minus ax plus 1? This equation looks like this graph. This is what we are interested in. So how will the graph look like? This graph will look more weird actually. Listen carefully. Vy graph, and you can clearly see here when you project this, the particle is going up, y is positive. Particle is coming down, y is positive. Y is always positive. The graph must be in the first and the fourth quadrant. And this is this kind of a parabola. We just now showed this graph will look like this. So this will decrease, decrease, decrease. It will reach here. So initially your speed is u. When will the velocity become 0? At h max. So this point will be your h max. Then you'll go down. This will be minus u. And we know h max is nothing but u square by 2g. So this is proportional to u square. So next time after collision, the speed becomes u by 2, but your h max becomes h by 4. So this will be like this. This point will be h by 4. Next time the graph will be like this. Next time the graph will be like this. It's like onion ka shells. The graph will just keep on putting layer upon layers. Right, Arya? Is this clear? The biggest headache here is knowing the graph actually looks like this. The mathematical part is the headache. It's a horizontal parabola. This is how the parabolas look like. This much you should have an idea. Maximum they'll teach you in more detail. So you'll get this concentric parabolas.
Sir, wouldn't that be x square is equals to minus ay plus 1?
Which one?
Sir, the parabola, the horizontal parabola,
X square is equal to
minus ay plus 1, because we are taking horizontal line.
no, देखो ना, for a given x coordinate there are two y coordinates. If you write, you're saying x square ऐसा, then x square तो ऐसा हो गया ना रे?
Oh, my bad, my bad. There is a quadratic function in y.
All clear with this? Others scams on? This is your vy graph. अभी तो question हुआ नहीं. What? When I said last question, you guys thought अभी 5-2 minute में हो जाएगा. We all can go. What about displacement time graph? I know when I said last question, people's faces started shining. You guys didn't realize like the question will be big. Okay, we're almost done. हो जाएगा 4-5 minutes. What is displacement time graph? Yeah, physics teachers are evil generally, so don't do anything. So if they ask you for distance time graph, you need to know displacement time graph. So look at the displacement. Y is equal to ut minus half gt square. Right? This is also a parabola. This is how the graph looks. So the displacement first will increase and then it comes back. So this is how the parabola looks. It's a downward parabola. And if you look at the values here, this will be your h max. This will be your time of flight. So every time it hits the ground, the parabola becomes smaller and smaller and smaller and smaller and smaller and smaller. It ends. So the time becomes t by 2, t by 4, and so on. The graph will end at 2t. And the heights will become h by 4, h by 16, and so on. This is square function. This is how the parabolas look. Clear? This is displacement time graph. Can you draw distance time graph? And remember this, anytime they ask you to draw distance time graph, you need to draw first displacement time graph. Using this graph, can you draw distance time graph? Get this. Think I'll give you a minute. Do you remember I told you something? Distance will always increase. Distance can never decrease. So take this graph and then use this graph to draw the other one. Look at the idea here. So in this graph, right, wherever the parts which are decreasing, flip them. So if I have to draw the distance time graph, distance is always increasing function, meaning you go up or you go down, it has to keep on increasing. So in this graph, look at the parts which are decreasing. Look at this part. This is decreasing. So this is not acceptable. This is decreasing. This is decreasing, and so on. So the graph will look like this. As long as you're increasing, there is no problem. Whichever part is decreasing, flip it. Now it is increasing, no? Then this part is increasing, so no problem. Just add it. This part is decreasing, flip it. This part is increasing, add it. This part is decreasing, flip it. Are you getting how to draw this? So every segment that goes down, flip them, because the distance is always increasing function. Flip the parts which turn down. Since distance is increasing function. Is this clear, everyone? All got this? There, that is a good question. So definitely make sure to do this. We have touched 88 questions. So with that, we are done with kinematics. Quite a big chapter, right? So do finish it off. I'll send you a sheet on graphs also today. And after this next class, we'll start off with units and dimensions and errors. Units and dimensions are easy, but like I said, errors is more important. Errors is really important. Every year they ask at least 2 questions in advance based on that. So we will do that because later on in other chapters also, that errors will keep coming. Again, it is a small one. Mostly we should wrap up in 3 classes. And then we will go ahead with loss of motion and everything. Okay, with that, we'll wrap up for the day. There was a test online today. I hope everyone has given. In case you have not given, there's a deadline till 11:30. You can still give. With this, we'll wrap up for the day. So first of all, make sure to go through the entire notes, revise once. With that, we'll wrap up for the day. So I'll see you guys again next week and Tuesday, same time. So any doubts, anything, you can stay back and ask, or else you're free to leave.